Hi my friends, today we model this part, a sheet metal part with many features. The drawing is this one. I work very hard to create these drawings because I start from a picture on the net and I have to create everything here. We start by creating this face, button face, with dimensions 112, 200. The thickness is 3, and the style of work is with sheet metal. New sheet metal part, not standard millimeters, sheet metal millimeters. Double click and start sketch. The sketch is this. The plane for the sketch is here, and I draw a rectangle with dimensions 112, tab 200. I place this midpoint on the center point and I have a fully constrained sketch. Finish sketch, and I don't go to face, I go to sheet metal defaults because I want to change the thickness, not 0.5 but 3 millimeters. And now face, okay, that's all for the moment. Then we see here flange with on the full length of the part with the dimension of 50. Nothing simpler. Flange, select the edge, not this one but this one, and place the dimension 50. That's all. On the other side there is a cut here, and then two flanges, different flanges. So we apply cut on this face and we use dimensions 42, 40 and 10. A rectangle, 10 on 40. This dimension is 42. Finish sketch. Now we have two closed areas. I select this one, of course. Okay. Another cut is here, as you can see. Its dimensions are here, 50 on 16. Cut, face, rectangle, (50, 16). Now I make this as a construction, and you'll see that Inventor finds only this face because the other doesn't exist. Okay, now the flanges, as I said. One of them is this, and it has the dimension 20 between this edge and this edge. The other one is 50. this one 50. Let's create these two flanges. Flange 20 plus flange 50. Okay. Next is this flange, and I want you to note that it is outside of this face 200. How much? What is the difference between these 2 points? That difference is here, my friends. And you have to know that if the thickness is 3, the radius is also 3. This means why we see here 6. Okay, then let's use the tool flange. Flange, I select this edge and I change the default options by moving this to outside, modifying the placement, modifying the position. This dimension is 45. Let me change this to go further. This is not 112, not all the distance, but minus 6 and minus 6 on the two ends. Here is a distance, you see, 6 and 6. Good. I have to select an option. Offset is the option, and here is applied 5 millimeters here and 5 millimeters here. You observe that this is on the axis, this 62. Good. We apply an expression here. This is 112 minus twice 6 minus 62 and dividing by 2. The same expression, I copy this here and I hope to place a good expression. Okay, let's see. Measure this 62. Okay. Another cut is this one with dimensions 14 on 7. We apply cut, select the face, make this construction to have not a close contour, then a rectangle from this corner on 14 tab 7. Finish, and you see the cut is already created. Next is the opposite flange, but this is special. Why? Because you see it has a curved end up, so that we create a flange with a certain height, but and we'll use it then for creating the other end of this flange. The distance is 48 instead of 62, and this part of the flange is also outside like before here. Good. I select, you see this is the detail, and I'll create a height of say 15 here. Then I continue with the other end to fulfill the dimension of 35. Let's do this. I apply flange on this edge, and this dimension will be 15, as I said. I also use offset. Here is an expression of 112 minus twice of 6 minus 48 now divided by 2. This is one end. The other end is by copy, paste the same value. You see, I keep these two options, not the default options, because I want to be outside this face. Okay, measure this, and this is 48. Good. Now we have to create a special flange, and to do this I select this face and I draw some curves here. Let me make this construction. They don't participate here. Line from this up, press the left button, go to the left up, then press the left button of the mouse, go here, pressed once again the left button and go up. You see, these two are equal, these two arcs are equal. This dimension from this face to this point is 2 millimeters. This radius is 6. This radius equal to the other is 5. And the position is 35. For this, and I must move this to be at 25 as in the drawing. 25. This is the sketch for the new flange. The new flange is not this one, but contour flange. We select the profile, this is the profile, and we select the edge along the flange is created. Okay, very good. Now I want to create this contour, this one, you see. I start with this. This is radius 25. We apply corner round for this edge with a value of 25. Okay. Then we have to place cut. 2 cuts. You see dimensions here. This sloped line, 22 at 20 degrees, 10. Then this contour up. This is a cut, and the other is 12 on 12 on 16 and 30 millimeters from the right. All of them are from the left. Or I rotate this and I apply cut on this face of a rectangle 12 by 16. This is 16, tab 12, placed at 12 millimeters from up. And 30 from the right. This is one cut. The other one is here. Line, down, press the left button and go to the left on the same horizontal. Then up, left, and sloped. This is 22. The angle is 20. This dimension is 10. This is 6. There is another dimension which I missed, my friends. Let me place that dimension. I don't modify the part. You see? I place a dimension here, which is 16. I place it somewhere up to have room and to see better everything here. This was missing. Okay, dimension from this point to here is 16. One dimension needed. Which one? This one. I don't measure this, but I measure this one. The dimension is in the drawing, 15. Okay, now we have 2 cuts. Finish, and we select not external, but this one and this one. Okay. Good. Next is this cut. 2 cuts, symmetrical about this line, with dimensions 40, 36, 14, radius 7, and 40. 2 slots. I use this face. I select slot, center to center. I draw a vertical line with the length of 14 and a diameter of 7 multiplied by 2. Dimensions now of the placement. This axis is placed at 36 from the left side, then this point from here is 40, and now it is fully constrained. So I create a cut. You see, I created a drawing and now I use cut, selecting this. Okay, I apply mirror of the last feature about what plane? This plane. Okay, and I hope the distance here is 40. Let's verify. Measure from this line to this line is 40. This is the step. Good. Another cut on the same face is this rectangle, which has 45 width, and it takes dimensions on vertical from these two lines. Good. I apply cut for you before creating the rectangle. Rectangle, not this one. Rectangle, normal rectangle with this dimension of 45 and aligned with this point and also with this point. Finish sketch. This is what we want to cut. Okay. Now I want to apply fillets. You see, this part has a lot of fillets, which are called corner round in terms of sheet metal part. You see, only this is not with corner round, and also here. What is the dimension? Radius 3. Good. Corner round of 3 to all that edges. Many radius 3 fillets. I hope I don't miss anyone. That's all. Okay. Now the holes 1, 2, 3, 4. Dimensions are diameter of 8 for all the 3, 1, 2, 3, but also this one. The distances are here and here. 34 is to both and 8 is this. We can create that holes in many ways. I select cut. This face, I place 3 circles of diameter 8 1, 2, 3. They are equal in diameter and they are on the same horizontal. If this is horizontal, yes, it is. Dimensions are 48. No, between them is 25 for this and 75 here. 75. Oh. And 75 from the center to center. 75. And this is 48. The other is 34. Finish sketch. I select every, apply cut again. Cut to this, to these 3 holes. Okay. Now also cut this face, F7, circle of 8, distances from the center, dimension here is 8 and the other direction is 34. Finish sketch. Oh, 34 from this, not from that one. Let me modify. 34 is not here, but here, this face. I have to project this face, and now I have a line somewhere. Look at it, this one. I apply 34 from the center to that line which is here, 34. Finish sketch, cut this, okay. It seems to be finished. Let's see what is the volume. Part 2 is physical update, copy, close, drawing, double click, and the new value is just the same. Cancel, I keep the previous value. Okay. Now I create for you a flat pattern to see how it looks. These are bending lines and you know everything. I go back to folded part. I apply material which is steel carbon. and eventually view shaded. This is the part, and we can compare with the other one, but this is perspective. If I change perspective here to orthographic, we can compare the two, but let me change also the colors. Two lights, not IBL. You see? Oh, this is not, this is aligned on vertical, but the other isn't. But why the volume is the same? Because it doesn't matter where is this placed, because the volume is the same. Let me modify this. The cut was this. No. This one. Double click, and I have to place on the symmetry axis this sketch. Double click, and I place on the same vertical this point with this point. This is a mistake, a difficult mistake, because the volume is the same, only the position is different. Take a look now to both. You see, nothing different. That's all for today. Thanks for watching. Bye bye.